This is JP, and this is Dave, and they're with FormLabs. And so what the heck is FormLabs do? What is that all about?
We make high precision 3D printers. So this is our second generation printer here.
Come show it to me.
Sure, it's the Form 2. We just launched this back in late fall, or early fall actually. And what this is a stereolithography 3D printer. So
say that again slowly, because I'm like a stereo.
Stereolithography.
Stereo
Lithography.
Lithography.
Impossible
3D printer.
Yeah.
Okay. Because it sounds like something out of Dr. Seuss right there. So
yeah, I mean the word is not ideal.
So explain to me what stereolithography is.
So the concept is basically you have a laser which is photocuring a resin. Right now the resin is just a liquid at room temperature. There's no special heating or melting going on.
Okay.
And what you're doing is there's a...
Come on, Dave, come get over in on this, man. You're like over there like hiding, so...
There's a photo initiator in there which causes a chain reaction to basically harden the liquid resin into a plastic.
Okay, so the light from the laser hardens the resin
into basically an acrylic plastic.
So why is that better than a typical 3D printer? Well, wait, let's have Dave answer that one. Dave, why is this better than a typical 3D printer?
The detail that it can print at is significantly better than the normal extruder printers that you're probably used to. It can print all the way down to 25 microns, which is very high detail. If you look at some of these designs, it can also print more complicated pieces than other printers. An extruder or FDM printer that you're used to seeing can't print a complex design like this. It can print it in pieces and then you'd be able to assemble it.
Right.
But our printer was able to print this as one solid piece. And if you look right here closely, you can see we actually were able to print the threads into the piece as well, which is not something that those extruders can do. That's something you'd have to machine into it after. So that's pretty cool. This is actually a shoulder piece for a robot. One of our robotics customers made as a prototype.
That's awesome.
That actually works on the shoulder of the robot.
Okay, so we get more detail. We can
print different things.
Potentially
more complicated designs. It basically has a higher ceiling in terms of use.
Does it save money when I do it that way? Is that like because it seems to me like this is kind of an industrial type of product, right?
So it is, but it's comparable in price to those other printers depending on what you're printing and how you're printing and that type of thing.
Okay, so you're at an EdTech conference. You're here at TCEA. Why would I use this in a classroom? What would be some of my uses for this in like a makerspace environment or something like that?
You can do things like this you can't do with an extrusion printer. So you can do a lot more robotics applications because you do fit and finish, like you can put a part right into an assembly and it'll guarantee that it'll be accurate within design tolerance. So you don't have to spend a lot of time like filing things or finishing things. You can do a lot of like applications in the wet lab, so you can actually do millifluidic testing because it's a watertight material. It's a lot more heat resistant.
Can they color this material, or is it always this?
It can be painted.
Yeah.
It can be painted. Wait, oh, he's going to show me. All right.
Fine art students, you can do a lot more digital sculpting. So,
and who's this guy?
This is Benedict Cumberbatch, the actor who plays.
Wow, he looks a lot different in real life. Yeah. I tell you,
he's a lot bigger in real life.
Wow, I have no idea why that just did that. Okay, let's go. Let's see. Why are you doing that? You must be excited to see Benjamin Cumberbatch, I guess. Okay, so that's Benjamin Cumberbatch, and so. Okay, so that's pretty cool. That's good. So that's like an art kind of project kind of thing. And so you said it also prints way like down to
25 microns.
25 microns. So what would be an application that you're printing something at 25 microns?
Anything that you want to be extremely high detailed. One of the more common things that we use for that is artisan jewelers. This printer has become very popular with them. What they can do is they can design very complicated rings, bracelets, necklaces on their computer with their CAD software, and then our printer can print it with all of those details that they put into it on the computer.
That's cool. That's cool.
And then they're able to use those prints with one of our special resins called castable resin to go through a burnout process to create a mold for that, and that mold retains all of the detail that they designed.
So the resin is proprietary. You have to buy the resin. Only FormLabs resin works with the FormLabs printer. Is that correct?
That's correct.
Okay. So is there a way, I'm going to ask her, is there a way to take that off so we can see what's going on in there? Or?
I can show you over here.
Okay, that's cool. Let's walk over there and see it. And so this is what the resin looks like. These
Yes.
are like, okay, so is it like crazy expensive, like inkjet ink?
This is $150 a cartridge.
Okay, so how much would that last me? What would that get? What would that print me out?
That latest that you saw over here that it's printing,
Right.
Right now, we can print about 7 of these with 1 liter. This is a big, complex design, though.
Okay.
So smaller things like these chess pieces that you can see down there,
Right.
in that cube, we can print significantly more with a single liter.
Okay. So where does this go? Does it go in the bottom? How,
It actually comes in the back right here.
Okay.
So you take the cartridge.
Okay.
So this is our clear resin. You just drop it right in the back. No problem. Pop the little vent at the top, which allows the resin to dispense down here automatically into this tank area.
So it took a while for Dave to get going, but once he got talking, he really got talking. Good job, Dave. Yeah, okay.
This is what I do. So it's very easy to set up. You slide the cartridge in the back. This is the build platform that the designs are made on. Our friend Benedict was printed on this upside down.
How long did it take Benedict to, wait, let's ask over here. How long did it take Benedict to print out?
That object was probably about a 10 to 11 hour print.
10 to 11 hour print, okay.
Most of the print time is determined by the actual height of the object because the slowest part of the print process isn't the laser etching it, it's like the raising of the build platform and resetting for the next layer.
So okay, so like, and I'm old, and so I have like my experiences with things like inkjet printers. So I know that with inkjet printers, what would happen is if you didn't use them, the little print heads would get clogged, and you just ruin the whole. So if I let this sit for like a month or two without using it, does it get clogged up, and I have to know it?
No, it doesn't. This wiper goes back and forth between each layer of the print, and when you start the printer up again, like if you haven't used it in a month, it'll slide back and forth to remix the resin and make sure it's not congealed in any corner of the tanks or anything.
And so this hooks up to your computer in the back? Is that how that works?
By USB or by Wi-Fi, actually. You can send your files over. Our software is a free software called Preform. You can download it on our website anytime you want.
Do you have like a community of makers that are like putting different things up there?
Yeah, we actually have a pretty active forum on our website. So
that's cool.
We have probably a couple thousand members on our forum that are pretty verbal.
Are the files proprietary? I mean, you have to use like
you can use any type of 3D printing software, like CAD software that you have. Tinkercad, Onshape, SolidWorks, whatever you guys are using.
Cool.
You can use, as long as you save it as an STL file, you can send it to our printer, and it'll work with our software.
That's awesome. So let's talk price real quick. What's the price of a printer like this cost?
It's $3,500, and it comes with everything you need to get started. So a liter of resin, and it comes with a kit to do like the finishing process as well.
That's awesome. So what's the finishing process? What's that?
You saw on our friend Benedict over here, he was printed on supports.
Yeah.
The finishing process involves just cutting off the supports, usually because it's a liquid resin when it prints, it comes out, it's a little sticky.
Yeah, we don't want his nose to be too big or anything like that.
Okay, so what we recommend is you wash the part in an IPA bath, which is just any type of over-the-counter like isopropyl alcohol, for about 25 to 30 minutes, and then you just let it dry. You snip off all the supports and you're good to go. All of these parts can be painted or sanded down for finer detail. This guy was actually printed at 100 microns, which, and I told you already that.
And that's why he looked so good.
Right, but so we can print at 25 microns, like I mentioned earlier, which is 4 times more detailed than what this guy is right now.
That's cool. All right, so if somebody's interested in purchasing the FormLabs printer, what's the name of the printer again?
Form 2.
The Form 2 printer. Who do they contact?
You can go to FormLabs.com and ask to talk to one of our sales team members.
FormLabs.com. And is there a deal if I buy 50 of them? Do I get a deal?
We look at deals on case-by-case basis.
If I buy 1 million of them, do I get a deal?
I think we can work
Get the price down. Yeah. Okay. All right. Thanks for talking to us, guys. Say hi to El Paso, Texas.
Hi, El Paso.
Hey.
Okay. Thanks.